Completing the square. So far, we've seen a few ways to solve a quadratic equation. We've taken a look at solving them by graphing. We've taken a look at solving them through factoring. We want to take a look at solving them by completing the square and by the square root property. Oh, and by the way, we also learned how to solve quadratic equations using the quadratic formula. So again, today we want to take a look at solving through the square root property and through completing the square. So we'll start with the square root property. Very easily, the first thing you want to do is to solve for x. Just isolate the x and you've got your answer. So just like any other equation you would solve, for example, here we're going to add 25 to both sides. So we have x squared equals 25. We want to take the square root of both sides now to solve for x. So I take the square root of x squared is x. And the square root of 25 is positive and negative 5. Remember that square root has two roots, a positive and a negative. In this case, 5 times 5 is 25, and negative 5 times negative 5 is 25. So both 5 and negative 5 are square roots of 25. So we include both of them in the answer. So again, basically to solve by square roots, we're taking the square root of both sides to come up with the solution. In this case, again, with the square root property, notice that on the left side, we have a perfect square trinomial. And if you recall, when you factored down the perfect square trinomial, it was a parentheses squared. We take the square root of the x squared, and that goes in the first position. We use the sign of the middle term, and we take the square root of the last term. In this case, it's 5. So x plus 5 squared. And again, that's equal to 49. At this point, we're ready to take the square root of both sides. So the square root of x plus 5 squared is just x plus 5. And the square root of 49, positive and negative 7. Finally, to solve for x, we isolate it. We have to subtract 5 from both sides. So we get x is equal to negative 5 plus or minus 7. Now, since we have no square roots here, we can separate these and solve for x in both cases. So we have negative 5 plus 7, and we have negative 5 minus 7. So in the first case, x is equal to 2, and on the right side, x is equal to negative 12. So our solutions here are negative 12 and 2. Okay, another problem here where we're going to solve by square roots. So again, we notice that on the left side, we have a perfect square trinomial. So again, we'll factor that down. So we're going to have x minus 3 squared is equal to 32. Again, square root of x squared in the first position, the sign of the middle term in between, and the square root of 9 in the last position. We're ready to take the square root of both sides. So we have x minus 3 on the left. And you notice that 32 is not a perfect square. So in this case, it'll just be the positive and negative square root of 32. The next thing we want to look at is, are we able to simplify the square root of 32? So in terms of the square root of 32, we can break that into the square root of 16 times the square root of 2. Square root of 16 will become 4. We're left with the square root of 2. So simplified, the square root of 32 is 4 square root of 2. So our next line will be x minus 3 equal to positive and negative 4 square root of 2. Now to solve for x, I just have to add 3 to both sides. So we have x equals 3 plus or minus 4 square root of 2. And we're in simplest radical form. If they wanted us to go beyond simplest radical form and give our answer to 1 or 2 decimal places, again, we could separate the equations and put them in the calculator to come up with the solutions. Okay, same thing here. Again, we notice that we have a perfect square trinomial on the left side, so we want to factor that down. So it'll be x minus 5 squared. We want to now take the square root of both sides, so x minus 5 is equal to positive and negative square root of 12. Again, 12 is not a perfect square. At this point, though, we have to look to see if we're able to simplify the square root of 12. So as far as the square root of 12, we can use the square root of 4 times the square root of 3. So this will become a 2, and we're left with the square root of 3. So we'll have x minus 5 equal to positive and negative 2 square root of 3. To isolate x, we just add 5 to both sides. And again, in simplest radical form, 5 plus or minus 2 square root of 3. So that's solving using the square root property. Here we need to solve by completing the square. If you notice that x squared plus 8x minus 20 is not a perfect square trinomial. So by completing the square, that'll help us get a perfect square trinomial so that we'll be able to solve the problem. So the first thing when you have something like this is to move the value of c to the other side of the equation. So in this case, we'd have to add 20 to both sides. So we'll have x squared plus 8x. Now I'm going to add a blank here. On the other side, we have 20, and I'm going to add a blank there. If I add a blank on one side, I have to do it on the other to keep the equation in balance. Now, to get the number that's going to go in the blanks, it says take half of the value of b, square it, and then add the squared value to both sides. Essentially, what this note is saying here is that you're taking the value of b, dividing it by 2, and you're squaring that result. So in this case, 8 is our b value. So it's 8 divided by 2, and we're squaring that amount. So 8 divided by 2 is 4, squared is 16. So 16 is the value that has to go in the blanks here. So the next thing we want to do is combine the right side. So we'll have x squared plus 8x plus 16 equal to 36. So now you look at the left side and you notice that we have a perfect square trinomial. So we want to use the square root property now. So we'll factor it down to x plus 4 squared equal to 36. Now we're ready to take the square root of both sides. So we'll have x plus 4 equals positive and negative 6. Isolate x, subtract 4 from both sides. So we'll have x equal to negative 4 plus or minus 6. Now, since we don't have a radical here, we can separate these and solve each one. So on the left side here, we get 2, and on the right side, negative 10. So our solution for this one is going to be negative 10 and 2. All right, so here they want us to solve the equation by completing the square. So you notice something a little bit different with this one. We notice that the leading coefficient is greater than 1. Whenever that leading coefficient is greater than 1, we have to divide everything in that equation by that leading coefficient. So for example, we'd have to divide everything here by 2. When we divide by 2, that's going to give us x squared minus 5 halves x plus 3 halves is equal to 0. At this point, now we're able to use the same steps that we used when the coefficient for the x squared was 1. We're going to move c to the other side. So I want to subtract the 3 halves. That'll leave us with x squared minus 5 halves x. I'm going to leave a blank equal to negative 3 halves plus a blank. Okay, so we have to fill in the blanks, and we know that filling in the blanks is going to be b over 2 squared. So in this case, we can use 5 halves over 2 squared. Now, essentially, this is the same when you're dividing by fractions. Essentially, it's the same as multiplying by the reciprocal. So it would be the negative 5 halves times 1/2, the reciprocal of 2, and that gives us negative 5/4. We need to square that, so we get 25/16. So we're going to fill in the blanks with 25/16. Okay, we're ready to factor out the perfect square trinomial on the left side. So that's going to give us x minus 5/4 squared. Remember, square root of the first term in the first position, square root of the second term in the last position. We're using the sign of the middle term in between. That's going to equal negative 3 halves plus 25/16. Okay, so if you're not a whiz in adding fractions and getting common denominators, again, you can do this right in your calculator. So we have negative 3 halves, and we're adding 25/16. That gives us 1/16. Okay, so that's equal to 1/16. We're ready to take the square root of both sides. So on the left side, take the square root. I have x minus 5/4. On the right side, positive and negative. So with the fractions, just take the square root of the top, take the square root of the bottom. So the square root of 1 is 1. Square root of 16 is 4. To solve the equation, we have to isolate x. So we're going to add the 5/4. So we get x is equal to 5/4 plus or minus 1/4. So at this point, we can separate them. So 5/4 plus 1/4. 5/4 minus 1/4. So on this side, we get 6/4, which reduces to 3 halves. And on the right side, we get 4/4, which makes 1. So our solution then will be 1 and 3/2.